such that two of the sides are the same. All right, so this is known as an isosceles triangle, okay? An isosceles triangle has two of the same, Now, what's gonna happen is that this is a bit weird, okay? So an isosceles triangle, and if two of the sides are the same, more than likely this is gonna be 90, 45, 45, all right? So let's look, you could also see it in this form. I just wanna make sure that I show you different forms. So this is going to be the base, and this is the leg, and this is the leg, okay? So a lot of people tend to think that the L stands for length, but in reality, the L in an isosceles triangle, that stands for the leg. So again, the legs are going to be the ones that are equal to each other, and then this is going to be the base. Now, if you go ahead and put it in this side, then this becomes kind of hard. Well, what is the height? You know that this is going to be the base, but what is the height? Well, that's why you have to use your critical thinking skills. Well, I don't want to have it in this form. I want to go ahead and tilt it such that I have this, and then I know that in fact, this must be 90 degrees here. Okay, now the reason why I give it to you like this is because I want to point out that you can have it as 90 degrees here. So then this is going to be L times L. So the area of this would be L squared divided by 2, or base times height divided by 2. So either one is fine. All right. L squared divided by 2, or B times height divided by 2. Any questions on these formulas? You're highly likely gonna use all of them today. So now, what is it that we're going to go over? Well, we're going to go over something called cross sections. So cross sections is the volume of any three-dimensional solid. Basically, the volume of any three-dimensional solid can be found using one or more of these formulas above, right? So far we've been using AX and AY. And you may be asking yourself, why does Contreras always want me to write this down? It's not only because it tells you what your formula, what the terms of your formula should be in. So remember, if you have X, that means that your formula for area should be X, but it is also helpful because area could be anything. It could be the area of a square. It could be the area of a triangle. It could be the area of a semicircle. It could be the area of an isosceles triangle. So it depends what it is that it's being stacked, okay? A disk is only one of the possible outcomes. So far, we've been looking only at disks. However, there are other shapes as well, okay? So we're now starting to see other shapes. So if we go ahead and go into your your work from today, which is on Delta Math, this is gonna be number 1. So I'll give you a couple of seconds to read it. I'll give you a couple of seconds to read it. And then I'll give you a couple more so that you can go ahead and draw this. Okay, so go to Delta Math, read it. You do not have to write down what it says, but I do want you to draw it. Okay, so go ahead and sketch it. Sketch the graph. So sketch the graph. Okay, let's see. Correct, this is number 1. Okay, let me know if you need more time to graph this. Now you don't need to draw the square that's there. I just drew it so you can have something to look at. So how it looks, okay? All right, so I'll go ahead and read it. Let the region R be the area enclosed in the function f of x, let's just call it that, and g of x. If the region R is the base of the solid, such that each cross-section perpendicular to the x-axis is a square, find the volume of the solid, okay? And then it tells you that you can use a calculator. Okay, so here, basically what it's saying is that you have the x, y plane, and it's flat. And what you're doing is you're adding an extra axis known as the c-axis, okay? So you're adding this extra axis, and what's happening is that you have this square whose base is on the function, as you can see here with the b that I drew. Let's see, where's my mouse? So here, this b right here, that's going to be my base, okay? And then what's happening? You're going to go ahead and add, some height into this. All right, so who can tell me what would be the height? What's another way to write the height of my square? So instead of putting h here, what can I put? Instead of putting h, what can I put? So come on, I need more answers. I only have about 9. So what is another? Yeah, so correct. So thank you. This would be b as well, right? So if this is a square, then the base and the height could be the same thing. So now it becomes a matter of determining what is, remember, you always start by making a sample disk or a sample cross section. Now in this case, you need to go ahead and find the area of this square. So how can I find the length of b? So how can I find the length of b? So think about it. This is almost like finding r. This is almost like finding r. This is almost like finding r. So you can think about it as instead of r, now we're trying to find b, okay? Yeah, so those of you who said subtracting the functions, that's correct. So which one goes on top? The one that goes on top is my linear function. Because remember, in reality, you're trying to find the area of this little thing from this small step to this small step, okay? So that's going to give you your height. So top f minus the bottom, right? So top or f minus g. So x cubed minus 1 minus 3x minus 1. Make sure, and I promise that a lot of you are still going to forget this, that you always go ahead and use parentheses when you subtract. So remember, it's the top one minus the small one. So you can put something like f minus g. B is equal to x cubed minus 1, and then close parentheses, and then minus 3x minus 1. Okay, this is important. Always put them in parentheses. Please, always put them in parentheses. And actually, it's the other way around, right? Because my 3x minus 1 is the top function. So this one's 3x minus 1, and this one's my x cubed minus 1. So I put them in the wrong order. And thank you for those of you who also pointed out. I really like the fact that you guys are following along. So this is going to be 3x minus 1 and x cubed minus 1. So then simplifying this is going to be b 3x minus 1 minus x cubed plus 1. So this is going to be x cubed plus 3x. That is my base. Okay. All right, now here comes the part Well, that is the base, okay? That isn't the area of the square. And now when I go ahead and write the area of the square, well, what is the area of the square? Give me the area in terms of B. What is the area of the square in terms of B? It's B squared, right? So now also another thing that I forgot to point out is that this one says perpendicular to the x-axis. So that's going to let you know that this is going to be, your integral is going to be in terms of x, okay? So all of these questions are in terms of x, but just in case you're wondering why did I go into x, it's because it's perpendicular to the x-axis. So they're being stacked on the x-axis. All right, so then a is equal to b squared. So a is equal to negative x cubed plus 3x squared. All right. Is there anyone who has any questions so far as how I found the area of the sample square? Anyone have any questions on how I found the area of the sample square? All I did was find b, which is basically the top function minus the bottom function. That's going to be the length, and then I squared it. All right. So then we already know that we're going to be using the integral from a to b, and it's going to be ax dx. And the reason why we use the integral is because we want to go ahead and now find all of the different squares. So I want to go ahead and find the squares, all of the squares on this shaded region. So similar to what you have here. So look at the computer, please. If you look at the computer, this is basically what's happening. So the squares are being stacked, okay? And remember, if we want to go ahead and stack an infinite amount of squares, then what we do is use the integral. The integral stacks an infinite amount of anything. We were working with circles. Now it's stacking squares. All right, so that's what we're stacking. So it's ax dx, and it's going to be a b. My a is going to go here. So that's going to be minus x cubed plus 3x squared dx. And now notice that this question tells you to use a calculator, okay? So if you don't have a calculator, what you can do is go ahead and download one from the App Store or from Play Store, I think it is. Yeah, from the Play Store as well. Is that why we don't use pi? Because the integral stacks an infinite amount of shapes. The reason why we don't use pi is because this time the area the area of a square doesn't include pi. So the reason why we were using pi last time is because the area of a circle used pi. But in this case, we're stacking squares. So the area of our sample shape is different. So the area of our sample shape here is a square. The area of what we were using before, it was a circle. The area of a circle is pi r squared. So that's why we would always put pi. Yes, if it was a circle, you would use pi. But because this is not a circle, then you use the formula that you need. So for example, our next sample, I believe, is a triangle. So a triangle, if you look at the formulas for a triangle, none of them have pi, okay? And then it is also possible, I didn't go ahead and include this shape, but it's also possible that they could give you a semicircle, okay? So if they give you a semicircle, then the formula for the semicircle is pi r squared divided by 2. So depending on what you're trying to build, especially if you're going into engineering, maybe you're trying to build a bridge, maybe you're trying to build, I don't know, a plane, you're trying to build different stuff, you're going to use different shapes, but the process is the same. You just need to identify what is the sample shape and then how you want to stack that shape. Okay. Any questions? Any other questions? Okay, so let me continue about the calculator. So in mine, I use this one. It's called Calculate X, and you can actually use integral for this. Now here, I believe I have another one. So you can either use Calculator X here or Calculate 84 or something like that. Yeah, Calculate 84. So if you don't have this calculator, please download it. Or if you don't want to use any of these calculators, you can also go ahead and use a Desmos calculator. The Desmos also has a calculator. And the question that I see in the chat is, can we use the calculator for the integral to solve it quickly? Yes. So for today, you will be allowed to use the calculator. Okay. So, but you do need to show me the work. Okay. I want to go ahead and see this work. So I need you guys to give me B, give me A, and also if you want to make it more balanced, just so you know, this is going to be A of X. Okay, so this is my A of X. So give me B, give me A, give me the integral, and then you need to use a calculator. So here, who can give me the first bound? So what X value does it start stacking by? What's the X value that it starts stacking on? 0, right? So 0 is the value that it starts stacking on. The hard one is going to be B. Okay, B is going to be this hard one. Okay, so there's no rotation for this one. Someone asked, is there rotations for this one? No, there's no rotation. All right, so for this one, now, how do you find the second one? Well, you have to use a little bit of algebra. So basically what you're looking for is for what X value, okay, for what X value do both of the functions have the same Y value, okay? That's what you're asking yourself. For what X value, and I'll write it down because I feel that it's important. For what X value do both G and F have the same Y value? For what X value do both G and F have the same Y value? Well, this one looks like a decimal, and the reality is that it's actually going to be a radical. So thank you for Daniel for pointing that out. That's correct. You would have to go ahead and set them equal to each other because remember, we want them to have the same Y value. So we want to set Y equal to Y. Okay, so Y equal to Y. The first function is 3x minus 1. And then my second function is, let's see, x cubed minus 1. And then you solve for x. You need to solve for x. So go ahead and solve it and then tell me what is the answer. So tell me for what X value are both of them the same? So solve for X and then tell me what's your answer. This is going to give you the second coordinate. So thank you for those of you who answered. This is 3x is equal to x cubed divided by 3. Divided by x. Divided by x, divided by x. These cancel out. 3 is equal to x squared. So plus or minus radical 3 is equal to x. And as you guys can see, I'm interested in the positive one. So radical 3 is the correct answer. So my B, which is here, this is radical 3. Okay. And then you could also use this arrow to point here. 0 and radical 3 is the answer. So then this would be radical 3, which we just found out. And then you put all of this into the calculator. Okay, so put this into the calculator. So again, I'm using Calculate 84. I already put the limits. If you don't know how to get here, let's see, how did I get here? I think it's math. Yeah, so math and then finite integral. So number 9, okay? So you go to math and then you go to number 9 and that should be your integral. All right, so we said negative, was it negative? Yeah, it's negative x cubed. And make sure that you put an extra parentheses. That is going to matter. So negative, let's see, where's my x? Okay, negative x cubed. And then plus 3x. And then close parentheses squared. Enter. And it gave me this as my solution. I don't remember. It said, I think, thousands, right? So we want to go ahead and approximate to my nearest thousands. So obviously, this is not the exact solution, but this is going to be an approximation. 3.5630. My thousands place is here. So looking at the number next to it, my final answer is 3.563. Is there anyone who doesn't understand how to use the calculator or doesn't understand any something from the problem? So in theory, this should be a little bit easier, but it can get hard if you're not understanding what we're doing. So please ask me questions. Okay. On school one, I can't pull up integral thingy. Okay, so I'll send you a video for the calculator one. It should be the same though. It should be math and then integral. Because Calculate 84 and the calculator that you guys have from the school is the same one. And I apologize. This is for the AP Calc students. What is the name of the calculator app? Calculate 84 is the app. So either of those two will work. Once you go on 9, do you press enter? Yes. So if you're using the calculator, the TI-84, you go to math and then you press 9 and then you click enter. And that should give you your integral. All right then, guys. So let's go ahead and move to the next one. Or if you have questions, put them in the chat, please. Okay, go ahead and copy down the graph and read it, please, for number 2. Okay, someone's asking, once you go to 9 and you press enter, what button do we push for X? No, it's not this one, it's this one. You press this one right here that says X, T, O, N. So these are all the different variables. These are all the different variables. So if you're looking at my computer, oh yeah, it's the computer. So my iPad, computer, whatever it is, this is gonna be your variable. And if you're using a different variable, it doesn't matter. It still give you the same answer. Okay. So let's go over this example and I'll explain how to do the calculator again after we do this one. Let the region R be enclosed by the function 2x squared and the horizontal line y equal to 8 and the y-axis. Okay, so this is important. This is going to be my y equal to 8 and this is going to be 2x squared, all right? And this is going to be perpendicular to the x-axis. So let's go ahead and draw a sample triangle because as you guys can see, they're telling you that this is going to be an isosceles right triangle, okay? An isosceles right triangle with a leg on the region, okay? This is important. Maybe you're not realizing how important this is, but this is going to save you from making a mistake. If they tell you that the leg is on the triangle, I mean, the leg is on the shaded area, that means that to find which formula, so let me go back to this one. So everybody pay attention here. Stop what you're doing and just try to think. If they tell me that my leg is on the shaded region, which one do I need to use? Do I need to use L squared or do I need to use base times height and then divided by 2? Which of these two do I need to use if the leg is on the XY plane? Okay, the leg is on the XY plane, all right? Yeah, so then you would have to use this one, right? You need to use the first one because the leg is on the XY plane, not the base. So that's why that key fact is important. You would have a hard time trying to find it with the other way. And we will eventually get to that, but for now, that's not the case. So in this case, let's go ahead and draw a sample. What color did I use for the previous one? Okay, I used green as well. So let's draw a sample here. And then what's happening is you have something like this more than likely. Okay, and it's popping out. All right, so you have this disk. I mean, not this disk, this solid. And you can think about it like that. All right, so you have this triangle popping out of there. Okay, and now the key thing is that the leg is here. Okay, so this leg is there. And therefore, this means that the height should be the leg as well. So the height is L as well. All right. Again, this is important. This is L. And then this is L as well. So my base and my height are both L. So then let's go ahead and make my L. What is my L equal to? Can somebody please tell me what my L is equal to? What is the length of my L? What is the length of my L? Let's make this one 8. Well, actually, y equal to 8 is correct. So top minus bottom, right? And then if you want to think it the way that we did it before, in a way, this is going to be my, well, this length from the top to the bottom, that's 8. And then you're subtracting from it this small piece, which is your bottom function. I mean, your bottom function, which is 2x squared. So that's another way to think about it. Again, you don't need to think about it that way, but it is maybe useful to visualize. So this is going to be G minus F. L is equal to G is 8 and then minus 2x squared. Again, always put it in parentheses. And it's going to be L is equal to 8 minus 2x squared. Okay, now what is my A of x? I think you guys can probably guess. A of x is basically the area of the sample triangle. What is the area of the sample triangle? Well, it's going to be L times L divided by 2. Okay, a triangle is always divided by 2. A triangle is always divided by 2. Okay. And then finally, I can get to my beautiful, beautiful integral sign. I love this sign, guys. It's so, I don't know, it's so smooth. It's also something that probably you didn't get before is that this is an elongated S. They call it the elongated S. And the reason for that is because the elongated S stands for sum. You're adding sum, the sum to infinity within an interval. So this is going to be from A to B, A of x dx from A to B, 8 minus 2x squared. And I made that too big. Divided by 2 on dx. And actually, I can now substitute my A and B. What is my A and B, guys? What do you guys think is my A and B? And also here, I went ahead and put a picture of how it looks. What is my A to B, guys? A to B, A to B. Okay, I think I'm going pretty slow, so let's step it up a bit. So this is going to be from 0 to 2. The reason for that is because we're looking at the x values, right? We're stacking them on the x values, as you can see here. They're being stacked on the x values. So this is going to be my 0, and they stop being stacked at 2. So now let's go ahead and use my calculator, or if you have the school calculator, go ahead and use that. All right. Again, how do you do this? You go ahead and go to math. You press 9. That gives you the lower bounds and upper bounds. I put 0. I put 2. Okay. Maybe I should write these down, huh? You're right. Thank you for that. Calculator instructions. So 1, click on math. 2, press 9. 3, I guess that's it. Oh yeah, put limits of 4. I wanted to add something else. Oh yes, x, t, theta, n are the variables. In this case, x. All right, so yes, we're just focusing on the green shaded parts. We're only focusing on the green shaded parts because that's the area that's bounded. So they already give you the area that's bounded, basically. All right, so where was I? Okay, make sure you use the correct amount of parentheses, x squared, close parentheses, divided by 2. And I actually need another parenthesis here, huh? So let's move this. And also there's a delete button. So if you ever mess up, there's a delete button here that you can use to fix your mistakes. And you can also move it to the sides. Okay, so then we put square. No, the square doesn't go there. The square goes here. Okay, so my answer is 133. And this one is to the nearest thousands, I believe, again. Yeah, nearest thousandth. So it's going to be approximately 34.133. And then rounding it. Oh, that's not the correct rounding place. Oh, yeah, it is. So 34.133. Any questions on this? Preguntas, please ask. All right, so the last one that I want to go over is number 3. I want us to do that one together, but I also want to give you the chance to try to figure it out by yourself. So this one's completely different. So draw it and then start it. I'll give you about 2 minutes. How do you know where to put the triangle? I don't. I just randomly pick a point. I randomly pick anywhere on the green shaded region. So for example, I could have actually picked it here. Okay. The answer is still the same, regardless of what you pick. So I could have picked that one. And the length, this little L, is still the same thing. It's still the top minus the bottom. Of course. So remember, you can draw it anywhere. It's still going to be the same answer. So copy down number 3, get started, and I'll walk you through the answer in 2 minutes. All right, guys. I'll go back to it, Daniel, in a bit. So let's look at this one. First of all, it is important to highlight that the rectangle whose height is twice the length of its base. All right, so twice. So if I go ahead and think about it, then first of all, let's figure out what the base is. So again, what is the base? What is the length of the base? So I have a couple of answers, but come on, let's get more. What is the base? In this case, it's going to be f minus g, right? Because it's the top minus the bottom. So there's going to be f is on top. So f minus g. So meaning that b is equal to f, that's radical x plus 1, and then minus my g, which is a half x plus 1. B is equal to, let's see, radical x plus 1 minus a half x minus 1. We can see that the 1's cancel out. So b is equal to radical x minus a half x. Okay. What is my a of x? Okay, so what is the area? What is the area of a rectangle? What is the area of a rectangle? Okay, base times height. All right. So here comes the part where you need to put your thinking cap on. First of all, we already know what the base is. The base is what we have on top, which I'm going to put in yellow. So I'm gonna put this one in yellow. So radical x minus a half x. What is my height? What is my height? My height is going to be 2b. So in other words, I can write a of x as b times 2b, all right? Because the height is equal to 2b. They tell you, rectangle whose height is twice the length of its base. So my height is 2b. So I'm going to go ahead and now put times 2 and then b, which is radical x minus a half x. All right. So then simplifying this will give me 2 radical x minus a half x to the power of 2. Okay. And if you wish, you can actually color this one. We can color it yellow so that you can see it more clearly. And that's my a of x. Yeah, twice the amount of the base. So finally, my integral. Okay, I also don't have my limits. Give me my limits, guys. Where am I stacking these rectangles? From where to where am I stacking the rectangles? Nice. 0 to 4 sounds about right. I don't like this color. A of x. And finally, from 0 to 4, a of x dx. So it's going to be from 0 to 4, 2 radical x minus a half x squared dx. And that's it. I think that you guys can go ahead and put this in the calculator. and you'll get your answer. Any questions on this? Okay. For your answer, just so that you can go ahead. So try doing it in the calculator. And if you don't get this, then it's wrong. It should be on 1.067. So practice putting it in the calculator and then put it in. I will be going ahead and making your breakout.